Welcome to Athlone Institute of Technology Open Day. My name is Andy Fogarty and I am the course coordinator of the BSc Honours degree in Microbiology, which is designated AL 839. Why would you do a BSc Honours in Microbiology? Well, this course was designed to provide highly trained graduates for immediate employment in the pharmaceutical, biopharmaceutical, medical device, food and brewing, environmental and industrial settings. This course addresses the core microbiological skills that are necessary to obtain highly paid employment. You can realistically expect upon graduating from this course to be earning somewhere between 28 and 32,000 euros as a starting salary. The core skills that we will be teaching you will be how to handle bacteria in a safe manner. It's a technique called asepsis or aseptic technique, which is a technique which protects the integrity of the sample, be it a vaccine, be it a food product, be it a beverage, or whatever. So you protect the integrity of the sample, you protect the operative who's making that product, and you protect the wider environment. In this course, we will be addressing key societal issues, such as producing food and beverage more efficiently and higher yielding food products. We will also be dealing with the use of microbiology in what's called bioremediation. Essentially what that is using microorganisms to turn pollution into safe products. We also will be addressing the production of industrial products such as medical devices and vaccines, and we have many such companies in Ireland who require graduates who can manufacture medical devices, biopharmaceuticals and vaccines in a safe manner. So why would you study microbiology? A little bit of advice for you. Choose a job you love and you never have to work a day in your life. So I want you now just to close your eyes and to imagine what type of a job you're going to be doing in 5 years' time. So go ahead, close your eyes. What kind of a salary are you going to be earning in 5 years' time, or 4 to 5 years' time when you graduate from college? What type of a car are you going to be driving? What kind of a house are you going to be living in? Are you going to get up out of bed in the morning and be happy of going to work? Now, you can open your eyes. Whatever you visualized, that's your future potential. You can make that happen. So by choosing the correct course, you can have a job that you enjoy, that pays well, and allows you to achieve your potential. The BSc Honours in Microbiology is such a course. You should now be starting thinking about your future. You should be looking at where the jobs are. So maybe you should start reading the Friday Irish Times or the Sunday Independent and look at the job section and figure out the trends of where the jobs are. Maybe once every 2 or 3 weeks, you might read a magazine called Science, or perhaps Newsweek or New York Times. This is a Newsweek article and it says the drugs don't work, because one of the leading issues facing humanity is antimicrobial resistance. Essentially, bacteria are becoming resistant to antimicrobials such as antibiotics. So the World Health Organization has predicted that one of the leading causes of mortality by 2050, i.e. 20% of the people on this planet will ultimately die from sepsis, which is blood poisoning. Now, you shouldn't be dying from sepsis. However, if you are unlucky enough to actually get a bacterial infection in your bloodstream, and that bacterial infection is resistant to antibiotics, there is very little we can do for you unless we come up with new antibiotics. It doesn't really matter what science course you picked. I would go back to one of my opening statements. Pick the course that you like, because if you like something, you probably will be good at it. And really, as long as you pick a STEM course, science, technology, engineering, or maths, you will learn the scientific method. So the scientific method is you have a hypothesis. If you look at the new Pfizer vaccine that was announced this Tuesday of this week for COVID-19, the hypothesis that Pfizer's came up with, that the SARS-CoV-2 vaccine should contain a surface protein that is on the SARS-CoV-2 virus. That surface protein is a protein called the spike protein. So the hypothesis is that if you get exposed to the spike protein, your body's immune system will recognize it and will mount an immune response. So Pfizer started their data collection in July of this year. They took 43,000 participants and they vaccinated half of them. The other half got a placebo. They then analyzed the results, and the conclusion was from this large-scale phase 3 clinical trials that if you are vaccinated with the Pfizer vaccine that contains a bit of genetic information that codes for the spike protein of SARS-CoV-2, you will have 90% immunity. Or indeed, to put it another way, 90% of people who were vaccinated with this spike protein messenger RNA were immune to SARS-CoV-2. So as scientists, we are evidence-based. If you ask employers, what do you want for a graduate? They probably will tell you they want 5 things. One of them is data analytics. Can you basically take complex information, can you analyze it and simplify it? So we live in a world of metrics. You are probably wearing a Fitbit or some type of a fitness device. You certainly have a smartphone which is capable of gathering a lot of data. That data then we have to make sense of it. So that data feeds up into the Internet of Things. And let's say, for argument's sake, that you have a smartphone and you're in a shop with location on. What will happen is that smartphone is sending information to the internet that there is a potential customer in a shop, and then you will get targeted ads. So that's how data analytics works in the computer science world. In the biological world, we have to be able to take complex information and we have to be able to simplify it. So if you look at this slide here, which states that 212 billion devices will be sensor enabled by the end of this year. As a scientist, we need to look at all that information, condense it, and basically come up with a decision that it is worth marketing your product to the person with the smartphone who's in a shop, in an electrical shop, or whatever. So that's what data analytics is. So we will be teaching you this in this course, and we'll be teaching it via a module called Bioinformatics and Computational Biology. The other core skills that employers are looking for is, are you an effective communicator, both orally and written? Are you a problem solver? Can you work as part of a team? Have you got attention to detail? So this BSc Honours degree in microbiology, which is the only one of its kind in Ireland. If you look at the CAO, there's only one course in all of the CAO which says BSc Honours in Microbiology, and that is this course here. So we have designed this course very much for industry, and we have asked industrial experts who hopefully will be employing you, what do they want from graduates? So this course is aimed at providing in-depth knowledge of microbiology, in particularly with emphasis on asepsis, resulting in excellent employment opportunities. So you should be a skeptic. You should begin to become a scientist. So I know if I was in my Leaving Cert and I was trying to pick a job that I liked and would give me good employment prospects, I probably would go to some independent websites, such as irishjobs.ie. And why don't you try that and put in the word microbiologist? I did this on the 12th of November, which was on Wednesday. And when I put in the word microbiologist, I got 225 hits. You try that for other disciplines and see how many jobs come up. And you can scroll through the 225 of these jobs and look at their locations, be it in Castlebar or Dublin or Kerry or wherever. So what is microbiology? Microbiology is the study of microorganisms, very, very small microorganisms, which are 10,000 times smaller than an ant. So they're absolutely tiny. Now, if we can get those microorganisms to do beneficial services for humanity, we have both added to the advancement of the planet, and we have got a nice job in the process. So some interesting facts about microorganisms. We actually, as humans, have 10 times more bacteria in our body than we have human cells. So we are sophisticated bacteria that is on a scaffold of human cells. The air that you are breathing now, 50% of that air, of that oxygen, came from microscopic algae called phytoplankton. And those phytoplankton were able to take the energy from sunlight, produce carbohydrates, and as a byproduct, produce oxygen. If we look at the human genome, humans have something between 23,000 and 28,000 genes. That's what codes for human life and human difference. So if we look at the human microbiome, this is essentially bacteria that are in your intestines, that are on your skin, etc. They have over 1 million genes. So sometimes those bacteria have genetic information that is very useful to us. One good example of this is a product called Humulin. So prior to the 1980s, so 40 odd years ago, if you were diabetic, type 1 diabetes, you got your insulin from a pig. It was called porcine insulin. So what happened was, we went to a pig, we bled the pig, we then extracted the insulin from the porcine blood, and we purified it, and we sold it as insulin. The problem with that is that porcine insulin varies. So in 1982, a company called Eli Lilly were able to excise or find the gene in the human that coded for insulin. They then cut out that piece of genetic information and put it into a bacterium that's in your intestines called E. coli. So now, if you're a type 1 diabetic, you get insulin which is produced in a gut bacteria which will produce insulin. And the beauty of this is that the insulin quality doesn't vary. We also can use bacteria for producing electricity in the energy that's in bacteria, and everyday kind of applications such as in chocolate, and it gives it this lovely melt in the mouth flavor. If you just look at your hands at the moment, there's more microbes on your hands than there are people on the planet. There is 7.8 billion people on this planet. There is infinitely more bacteria on your hands than there are people on this planet. And they're the good bacteria, because if a bacteria wants to cause infection, that bacteria has to outcompete the good bacteria that are on your skin and in your intestines or in your nasal passages. The World Health Organization, which is very much in the news at the moment with COVID-19, they have predicted by 2050, one person will die every 3 seconds from antimicrobial resistance. Essentially, that is, you get a simple infection that we could historically have treated with antibiotics. We still can, but we are rapidly running out of antibiotics. That's why the World Health Organization, they have predicted that 20% of the people on this planet will die from sepsis, i.e. blood poisoning, by 2050 if we don't come up with new antibiotics. If we just look at this information here from Public Health England, you are looking at 10 million deaths and a cost of 66 trillion sterling. Now, behind those deaths, there's real people. If we look at one of the leading antimicrobial problems in Ireland, it is a bacterium called carbapenemase producing enterococcus, CPE. If you're unlucky enough to get carbapenemase producing enterococcus, you potentially can die from it, because carbapenems are one of our reserve antibiotics. And now there's the emergence of a new type of bacteria which is resistant to this super drug. So that means in this empty chair, there's no grandfather, grandmother, aunt or uncle who has been unlucky enough to get sepsis and has died from it, because we don't have antibiotics to treat it. Now, if you want to make a difference, you could decide to do a course like this, study microbiology, get very good skills for employment, but you might also decide to go on into further research and try and solve the problems of antimicrobial resistance. We also can use bacteria to produce biodiesel. So there's the multitude of uses of microorganisms. So with that in mind, we designed the BSc Honours in Microbiology. So what skill sets are we going to teach you? Well, critical thinking, because employers want you to be able to solve a problem. They want you then to be able to scientifically communicate that by writing a good comprehensive report, by being able to look at very complex data and being able to simplify it. They also want you to have what's called aseptic technique. That's a technique that protects the integrity of the sample, i.e. in this case it could be a vaccine, and it also protects you, the operative. So how are you going to achieve these skills during your 4 years in Athlone Institute of Technology? Well, if you look at some of the courses you're going to be doing, you're going to be doing current scientific issues through inquiry-based learning. You're going to be doing learning and development in higher education in microbiology. In second year, and when you're choosing your course, will you please look at the 4 years of the course content? Most people only look at the first or second. So in second year, we diverge. We diverge into microbial methods through inquiry-based learning. So in this module, we give you the problem and you have to tell us what methods you're going to use to solve that problem. We're going to introduce you to applied microbiology. That means, can you actually do it rather than a theoretical? In fact, most microbiology courses should not be called microbiology. They actually should be called bacteriology. And bacteriology is the study of bacteria. Now, in this course, we understand that as well as bacteria, there are eukaryotic microorganisms, such as fungi, such as yeast, such as algae. So we will address this through a module called Microbial Systematics with Eukaryotic Microbiology. We also will give you applied skills like principles of sterilization, good manufacturing practice in third year. Industry came to us and said, you need to produce graduates who understand how industry works, how manufacturing works. So that's the module GMP. We have 3 pillars in this course: food with brewing microbiology, environmental microbiology, and industrial microbiology. Industrial microbiology encompasses medical microbiology and medical devices. In third year, you will be doing a placement. That placement is a minimum of 6 months. So semester 2 of year 3, you go out for a 20-week paid placement in industry. And in fact, industry like our graduates so much that they try to hold on to them for after the placement. But I would advise you, tempting and all as it is after year 3, stay with the program and come back and finish your degree, because 5 years time you will be getting a better job with an honours degree rather than a pass degree. In fourth year, you will be doing subjects like current trends in microbiology. We're doing advanced food and brewing, advanced environmental microbiology, advanced industrial bioprocessing. Here's the module I talked about earlier, computational biology and bioinformatics. That's essentially data analytics for scientists. Once you have done your experiments, you need to be able to do applied statistics. You need to design your experiment correctly. Hence, applied statistics and experimental design. This is an industrial module called quality management. You might have had come into college with a good idea that you want to develop, or maybe through your 3 or 4 years into college. So we offer a module called Innovation and Entrepreneurship, and we have a capstone project called the Research Project. So what that is that will be a culmination of 3.5 years of your formal training. We will give you a research project. You will then have to investigate that project. You will have to design experiments. You will have to collate your results, and you will have to communicate those results. And that is your research project. So why study microbiology in Athlone Institute of Technology? So in summary, the expertise of the lecturers involved, many of your lecturers that will be delivering this course have specific PhDs, which is the highest level of qualification in microbiology. We will be focusing on the core skills, and the core microbiological skills are asepsis, microscopy, can you enumerate organisms, can you isolate them, and can you identify them. I've gone through already, there is a minimum of a 20-week mandatory work placement, so maybe look for courses that have placements in them, because that is a good way for you to get real life or real world skills. This degree program is specifically designed to have industrial focus modules such as good manufacturing procedure, principles of sterilization, industrial bioprocessing, etc. And as I asked you earlier on, check out irishjobs.ie, the Friday Irish Times, the Sunday Independent, publicjobs.ie, whatever platform you're looking at. Key in the word microbiology and see how many jobs come up. Now, don't ever choose a course because it's going to pay well when you are a graduate. Please pick a course that you are genuinely interested in, because if you're genuinely interested in the course, you will do very well in it. So, what are the careers in microbiology? You can work in the biopharmaceutical industry, such as Alexion, Regeneron, Jazz Pharmaceuticals. You can work in medical tech companies such as Boston Scientific, Abbott's. You can work in the food and brewing and agribusiness, such as Kerry Foods, Glanbia, Diageo. You can work in water treatment and pollution control. You can work with companies like EPS, the EPA, clean room facilities. You might say, how does microbiology equip you to work in Intel? Well, if you can keep a bacteria from contaminating the products, you sure as hell can keep a little bit of dust from contaminating a chip in the likes of Intel, Dell, etc. If you want to pursue a career in medicine, a good first step on your road to postgraduate medicine would be a degree in microbiology, where we look at antimicrobial resistance, we look at bacterial pathogens, medical microbiology, etc. And you also can get jobs from this course in the government, EPA, Teagasc, HSE, etc. So just to finish up here, Ireland currently supplies 10% of the global infant milk formula. That means 1 in 10 babies on this planet who have infant milk formula in a bottle. That is coming from Ireland. That figure is set to increase to 15% by December 2022. So this is a growth area. The agri-foods industry needs microbiologists to be able to produce that infant milk formula in an aseptic manner. Lots of distilleries are popping up around the country. Jameson is the second best selling whiskey in the world. So we have a huge pedigree in Ireland in distilling. If you look at the biopharmaceutical industry, in Ireland, 9 of the 10 top global biopharmaceuticals in the world are in Ireland. 15 of the top medical technology companies are in Ireland. So finally, perhaps you should go and talk to some of our students, or at least read their profiles, who have done this course. So here is one student, Kevin Temple, and in Kevin's own words, the course uses inquiry-based learning to prepare you for a career. Not theoretical, prepare you for a career. This degree was created in response to a skills gap in industry, and as such is producing the kind of highly specialized graduates that employers are crying out for. So Kevin, on his placement, his employer basically said to him, is there many more graduates like you in Ireland? He said, well, no, this is the only course. Yeah, this is the only ab initio BSc Honours Microbiology course in the country that is industrial focused. Here's another student, Katie Fair. Katie said, the first thing you'll notice at Athlone Institute of Technology is the friendly family atmosphere. Everybody is ready to help you achieve your potential. I will guarantee you, whatever course you choose in Athlone Institute of Technology, the staff will help you achieve your potential. All we ask of you is you have a good attitude and you genuinely want to learn. And then you will truly achieve your potential. So in summary, this course highlights include a work placement, inquiry-based learning, problem solving, data analytics, and communication skills. This is the only dedicated microbiology degree on the CAO system currently. If you need any further information, please email me, Andy Fogarty, and my email is afogarty@ait.ie. Thank you very much for your attention.